So we'll go through one more problem using stoichiometry and Avogadro's number in it. This one will also use Avogadro's volume constant, which is 22.4 liters per mole of any gas at standard conditions. And as always, we're going to assume that because we're working with volume in these problems, that we can assume for now that we're working at standard temperature and pressure conditions so that we can use that 22.4 liters for any 1 mole of gas. That'll show up at the end of this problem. So for now, like before on the previous example, and if you didn't watch that, then you don't know this, but if you haven't noticed, these equations aren't given for these problems. You need to come up with the reaction equations. And this one's just a little trickier than the other one. It doesn't tell you everything right in the formula, or rather in the problem, but I think you guys can figure it out because you've done quite a few of these already. You're going to react, it says 3.01 times 10 to the 23rd atoms of zinc with hydrochloric acid. And wondering now how many liters or what volume of hydrogen gas will be formed. So we're going to react zinc with hydrochloric acid to make hydrogen. If you write that much out, you probably figure out the rest of the reaction. But it turns out that this is just a single replacement reaction, one that we've actually worked with before and done in lab. So zinc with hydrochloric acid, the zinc as a metal replaces the hydrogen from the hydrochloric acid and produces hydrogen gas, leaving zinc chloride behind. So here's the equation for that, and as always, you can rearrange the substances on each side of the arrow and it's just fine. But zinc here plus hydrochloric acid yields zinc chloride and hydrogen gas. Don't forget hydrogen's diatomic because that affects how you balance your equation. And after you balance your equation, you should have 1, 2, 1, 1 as your coefficients. Again, that's going a little quick through here, but this is old stuff, so we're not working with equations as much right now. And I'm just going to assume that you can figure these out or that you can get them from me, and we're going to go on to the stoichiometry problems. If you're still struggling with equations, don't forget to come in and get some more help because we can't go without that stuff being very fluid and confident for you as we continue on for the rest of the semester. So this is a very simple single replacement reaction, and it gives us in the problem a starting amount of zinc, 3.01 times 10 to the 23rd atoms of zinc. And again, that's going to be our only given amount, so that has to start out in the top left corner box as always. I apologized in the last video. I'll say so again. I'm sorry I don't have my writing tablet to do these with you and actually write them out by hand. I left it at home, and so they're going to have to be animations today. But 3.01 times 10 to the 23rd atoms of zinc, we need to convert that to moles. The beginning of any stoichiometry problem after you've balanced the equation is you need to convert it to moles if it's not already in moles, because that's how we relate substances to each other. So we've got atoms here. That's clearly not moles. Let's convert it to moles. We know that for any 1 mole of zinc, we use Avogadro's number. There are 6.02 times 10 to the 23rd atoms of zinc in that mole. And so we put that on the bottom. Keeping in mind atoms of zinc needs to come down and to the right so that it cancels out. So atoms of zinc were on the top. Now they're on the bottom, and those would cancel out, leaving us with just moles. We're not going to stop and get an answer here because we're going to continue on with stoichiometry, but if we did get an answer, we would have an answer in moles. The next step is to find that mole ratio that connects the zinc that we're starting with to the hydrogen that we're trying to make. And keep in mind, the question asks what volume of hydrogen gas. It's not asking about the acid or the zinc chloride, it's asking about the hydrogen. So in this step, we'll link the zinc to the hydrogen gas. Now, moles of zinc are on the top, currently on the right here, and so we're going to bring that down to the bottom, and in front of it goes a 1. Again, not because this was a 1 up here, but because in my balanced equation, the zinc has a coefficient of 1. You can see it in red, and so I bring that red 1 down here again. 1 mole of zinc is put into this reaction, and according to my balanced equation, for every 1 mole of zinc that I put in, I get 1 mole of hydrogen out. It's a 1-to-1 ratio. For every mole of zinc, I get a mole of hydrogen. So it's pretty simple. But keep in mind those 1s come from the same colored places there in the equation. All right. Now, if we canceled out the units again, moles of zinc would cancel, and I'd have nothing left but moles of hydrogen. The final step of our stoichiometry instructions tell us to convert, if moles isn't what you're after, convert moles into some other unit. In this case, we need volume, and liters are the unit that we use to measure volume of a gas. So we're going to convert our hydrogen moles into liters of hydrogen. Using that gas constant that we know, again, 22.4 liters of any gas per mole at standard conditions. So bringing moles down to the bottom right, 1 mole of hydrogen is equal to 22.4 liters of hydrogen at standard conditions. And again, we're assuming that that's the conditions we're working at for now. So in this problem, we've canceled out atoms of zinc, top and bottom. We've canceled out moles of zinc, and now we've canceled out moles of hydrogen. And all that's left is liters of hydrogen. If I punch this into my calculator using my scientific notation function, using parentheses to group the numerator and denominator together, which I encourage you to continue to do, in the end, that should give us an answer at about 11.2 liters of hydrogen. With 3 significant figures, I started out with 3 significant figures, and I kept 3 all the way through, so at the end, I'll have 11.2 liters of hydrogen as my final answer. So we can use Avogadro's number, 6.02 times 10 to the 23rd, in any problem, just like we can use 22.4 liters in any stoichiometry problem at standard conditions, and just like we can use grams of any substance from the periodic table and those average atomic masses in any problem as well. We've got those 3 choices: particles using Avogadro's number, liters using 22.4, and grams using whatever mass the periodic table gives you. And this is an example where we connect particles and liters together. That should leave you 3 more problems on the sheet. Work on those other 3. They're not too different from the ones that you've seen now in this video, and if you watch the other one as well. If you didn't watch the other video, feel free to do so, and that'll help you out with problem number 1. And I'll talk to you next time we're back together. Hopefully you'll have some luck with these, and we'll go over any questions you have then. See you then.